If we are asked to write the equation of the line with one of the given facts being a perpendicular distance, we can write the equation in terms of m and then use the perpendicular distance formula. So the example says, find the equation of the two lines which contain the points -5, -4, and which are at a distance of root 17 from the point 1, 3. Write the equation of the lines we want in terms of m, and then write this in the form of ax plus by plus c is equal to 0. So we're going to let m be the slope of the line we want, and the equation of the line may be written as y plus 4 equals m times x plus 5. So I got that from the equation of a straight line formula, y minus 1 equals m times x minus 1, with the point -5 minus 4 being labelled x1, y1. So we get y minus y1, so it becomes y minus minus 4, so y plus 4. M just stays as m, and x minus x1 becomes x minus minus 5, becomes x plus 5. Next, we're going to multiply out the brackets and rearrange it in the form of ax plus by plus c is equal to 0. So bring down the y plus 4, m times x is mx, m times 5 is 5m. We bring everything over the left hand side, so we end up with mx minus y plus 5m minus 4 is equal to 0. So the 5m and the minus 4, they don't have an x or a y stuck onto them, so together they represent the plus c value. Then the perpendicular distance from the point 1, 3, which we're going to label as x1, y1, to mx minus 1y plus 5m minus 4 equals 0 is 17. So remember, this is the new equation of the line, and we know that the perpendicular distance from the point to this line is root 17. So we're going to label the m as a, the minus 1 as b, and the 5m minus 4 as c. We know the point is 1, 3, so that's x1, y1. We substitute it into our perpendicular distance formula, and we let it equal to root 17. So we swap the a for m, the x1 for 1, the b for minus 1, the y1 for 3, and the c for 5m minus 4. And remember, we've got the modulus on the top of the fraction. This is all divided by root a squared becomes m squared, and b squared becomes minus 1 squared. And that's all equal to root 17, which we can write as root 17 over 1. And then we can cross multiply, rearrange, factorise, and solve. So simplifying the top of the fraction, m times 1 is 1m, and 1m plus 5m is 6m. Minus 1 times 3 is minus 3, and minus 3 minus 4 is minus 7. Remember, you've still got your modulus symbol. So that top line gets multiplied by 1 because we're cross multiplying, so it just stays as 6m minus 7 with the modulus. Then we have the equals. Then we're going to have root 17 multiplied by the square root of m squared plus minus 1 squared. So minus 1 squared just becomes 1, and we just stick on the root 17 in front. So we've got root 17 root m squared plus 1. Now we're going to square both sides to get rid of the roots. So 6m minus 7, we just put squared around it, equals root 17 squared is 17, and root m squared plus 1 squared just becomes m squared plus 1. Make sure you've got brackets in front of this, because remember, the root 17 was stuck onto it, and anything stuck together in maths means multiply. Next, we multiply out the brackets, so 6m minus 7 squared gives us 36m squared minus 84m plus 49, and that's all equal to 17 times m squared is 17m squared, 17 times 1 is 17. We're going to bring everything over the left hand side, so we get 19m squared minus 84m plus 32 is equal to 0. Now you can factorise, or you can use the minus b formula. So factorising, we get m minus 4 times 19m minus 8 is equal to 0. So we end up with m equals 4 and m equals 8 over 19. So m equals 4, we're going to let our m equal 4, so one of the lines is going to be 4x minus y plus 20 minus 4 is equal to 0. So we got these values by substituting into the actual equation of the line. So mx becomes 4x because we're letting m equal to 0. Minus 1y just becomes minus y. 5m minus 4 becomes 5 multiplied by 4 minus 4. 5 times 4 is 20 minus 4. And then 20 minus 4 is 16. So 4x minus y plus 16 equals 0 is one of the equations of the line. This is if we let m equal 4. Now if we let m equal to 18, so we get m times x, so this time it's going to be 8 over 19 times x, minus 1y, so just minus y. And then we have 5 times m minus 4, so it's going to be 5 times 8 over 19, which is 40 over 19, minus 4. That's all equal to 0. Then we can multiply across by 19 to get rid of the fractions. So we get 8x minus 19y plus 40 minus 76 is equal to 0. And 40 take away 76 is minus 36. So the other equation of the line is 8x minus 19y minus 36 is equal to 0. So we were asked to find the equations of the two lines which contain the point minus 5 minus 4 and which are a distance, a perpendicular distance of root 17 from the point 1, 3. So the equations are 4x minus y plus 16 equals 0 and 8x minus 19y minus 36 equals 0. So we can see it drawn out here on our xy axis. So we see this is the point 1, 3. These are the two lines. This is the point of intersection, minus 5, minus 4. And this is the perpendicular distance, root 17, from the point 1, 3.